Hello everyone. I am here to talk about multi-stage graph. Okay, so you know that what is multi-stage graph? Do you have any idea? Multi-stage graph. So this multi-stage graph is a directed graph and also it is a weighted graph. Okay, in which the nodes can be divided into set of edges. So I will show you one example for related to multi-stage graph. Okay, so let me draw one example here. I will draw one graph for you. Okay. So suppose we have a vertex 1 is there. Okay. I will tell you why this is known as multi-stage graph. This is 2. You also have to draw with me. And don't worry about my handwriting here. So this is the vertex 4. And this is vertex 5. Okay. You also have to draw like this. 6. This is vertex 6. This is vertex 7. And this is vertex 8. Okay, and another vertex, we have other set of vertex 9, and here 10, and this is 12. Sorry, this is 11. Just a second. Okay, this is 11. And we have our final vertex 12. So you also draw with me this vertex. Okay, so here you can see these are directed graph. I told you this is a directed graph. Multi-stage graph is a directed graph. So you can see the direction is also given like this. From 2, we have 3 parts. We can go to 6 from 2. We can go to 7 from 2. And also we can go to 8 from 2. Okay. So 3 parts are from 2. And we have 2 parts from 3. So we can go to 6 from 3 and we can go to 7 from 3. Okay. And only one path from 4 to 8. Only one edge is there from 4 to 8. Okay. And from 5, we can go to 7. There is a directed edge to 7 from 5. And there is a directed edge from 5 to 8. Clear? And now from 6, we have 2 edges. So from 6, we can move to 9, as well as from 6, we can move to 10. Okay. And from 7 also we have 2 edges. So from 7 we can move to 9. From 7 we can move to 10 also. From 8 we have 2 edges, 2 parts. From 8 we can go to 10 and from 8 we can also go to 11. Okay. And from this 9, 10 and 11 we have only one single path to our destination vertex 12. 9 to 12, 10 to 12 and 11 to 12. Okay, so this is our multi-stage graph. It doesn't look good, but for the time being, please accept this as the multi-stage graph. Okay, I will show you the good figure or the neat figure of multi-stage graph after some time. Okay, now let me tell you why this is known as multi-stage graph. So you can see that this is a vertex group 1. When you see this vertex V1, vertex group 1 contains only one vertex, okay, 1, okay. And this is our vertex group 2, clear? And here how many vertices are present? 3 vertices are present, 2, 3, 4 and 5. Sorry, 4 vertices are present. Vertex 2, vertex 3, vertex 4, vertex 5. And this is our vertex group 3, okay. And in vertex group 3, you can see how many vertices are present. 6 vertices are present. Vertex 6, vertex 7, vertex 8. And we have another set of vertices, vertex group 4. And in this V4, how many vertices are present? 3 vertices, 9, 10, and 11. And this is our last set, V5. And in the last set, only one vertex is present, and that is our last vertex 12. Okay. So a multi-stage graph is a directed graph and a weighted graph. So two features are there for this multi-stage graph. It is a directed graph, so you can see that the directions are provided. And also I told you that it is a weighted graph. So let us put the weights on each edges. Okay, so you can see the here we can here the weight for the edge 1 to 9 is 9. Okay, cost of edge 1 to 9, 1 to 2 is 9. Okay, and cost of edge from 1 to 3 is 7. Clear? And cost of edge 1 to 4 is 3. So let me put all the weights here. Okay, so hope you understand the meaning of weights. So this is 2 to 4, 6 is 4, 2 to 7 is 2. Clear? And 2 to 8 is 1. Okay, now about 3, where 3 to 6 is 2. Okay, 3 to 6 is 2. Okay, and 3 to 7 is 7. Clear? 4 to 8 is 11. 4 to 8 is 11. And 5 to 7 is 11. 5 to 7 is also 11. And 5 to 8 is 8. 5 to 8 is 8. You have to draw all these things in your notebook. Okay, so 6 to 9 is the cost of 6 to 9 edge is 6. Cost of 6 to 10 is 5. Cost of 7 to 9 is 4. And this is 3. And this is 5 and 6. 5 and 6. Okay. And here it is 4, 2, and 5. So as the definition tells that this multi-stage graph is a directed and weighted graph. So it is a proof here that it is a directed and weighted graph. And also one statement is also present in the definition. The definition says that a multi-stage graph is a graph in which the nodes can be divided into set of edges. So here the set of edges are there. Stage 1. Okay, set of stages. Stage 1. V1 is stage 1. Okay, and under the stage 1, how many vertices are there? Only one vertex. Vertex 1 is present. This is stage 2. And in stage 2, 4 vertices are there. In stage 3, 6 vertices are there. In stage 4, 3 vertices are there. And in stage 5, 1 vertex is there. In stage 3, 3 vertices are there. Okay, so and you can see one more thing. These within the stage, no vertices are connected to each other. Okay, no vertices are connected to each other directly. Okay, they are not connected to each other directly. So here also you can see 6, 7, 8, no direct connection is there. 9, 10, 11, no direct connection is there. Okay, here 2, 3, 4, 5, no direct connections is there. Okay, so how many things you have to remember about a multi-stage graph? It is a directed graph, it is a weighted graph, and all the nodes are divided into set of stages. And within the stage, no vertices are connected to each other directly. Okay, clear. So here we have given a multi-stage graph. This is a multi-stage graph and a source is there. So this is our source. Okay, this is our source vertex. This is our source vertex S. Okay, and a destination vertex is also there. This 12 is our destination vertex, and we need to find a shortest path from S to D. Okay, source to destination. And you know, one assumption is taken here. The source vertex is also present at stage 1 only, and the destination vertex is present at the last stage only. So here how many stages are there? Here 5 stages are there. So this graph is known as 5-stage multi-stage graph. Okay. Now, to solve this problem, what is the problem? We have to find a shortest path from source to destination. To solve this problem, we have two methods. The first method is forward approach and the second method is backward approach. Okay, in the forward approach, what happens? We are starting from the destination vertex and we will move towards the source vertex. And in the backward approach, what happens? We start from the source vertex and we will move towards the destination vertex. Okay, so here we are going to follow the forward approach. I will show you the algorithm at the end of the session. Okay, so let us start how to calculate the minimum cost shortest path from source to destination. So For maintaining this, we have to, for calculation, we have to maintain a table like this. Okay. So you also draw this table along with me. So how many total vertices are there in this figure? 12 vertices are there. So you have to draw 13 columns. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this is our 13. Okay. By 13, I will tell you. So you have to divide, you have created 13 columns. Why? Because 12 vertices and one extra column. And you are dividing this like 3 rows. You have to need, you need 3 rows also. Okay. So 3 rows are there. And now in the first row, the first column heading is, first row heading is a vertex. You are going to write all the vertices here in this row. And in the next row, the column, the row heading is cost. Okay, and this is our D. I will tell you what is this D at the end of the session. Okay, now let us fill the first row. So this first row contains a vertices name 1, 2, 3, 4, 5, 6, 7. This is 8. This is 9, 10. This is 11. And this is 12. Okay, so this wise you have to, likewise you have to keep a table also. And this table contains 13 columns and 3 rows. Why 13 columns? Because we have 12 vertices. So for entering all the 12 vertices, you need 12 columns. And for these title headings, you need 1 column. So 13 columns and 3 rows. And the first row indicates all the vertices. And the second row indicates the cost of the vertex, and D indicates the decision. Okay, I will tell you about D at the end of the session. Okay, so let us start the calculation. So as I told you that we are going to start from the destination vertex. Why? Because we are going to follow the forward approach. Okay, so now you have to calculate the cost of 12 here. What is the cost of 12? Okay, so cost of 12 is supposed to be 0. Why? Because there is no other vertices linked to this 12. From 12, we are not going to move ahead. Okay, so for this, you are going to assume the cost of 12 as a 0. So when you write this, how you are going to calculate? You are going to calculate cost of 12 is written like this. Okay, cost of 12. And this 12 is present where? This 12 is present at the 5th stage. Okay, so at the 5th stage, what is the cost of 12? At the 5th stage, the cost of 12 is 0. Okay, so this 0, you have to enter the value 0 here. You have to enter the value 0 here. So this 0 is the, for the last vertex, for the destination vertex, the cost is 0. Okay, and where this you are reaching, you are where we are pointing to which vertex? You are pointing to the vertex 12 only. Okay, you are not going to anywhere from this vertex. You are at the vertex, last vertex only. So you have to write that vertex. Okay, 12. The vertex which give you the minimum value, and here the minimum value is 12, so you are writing 12 here. Okay, so now you are you are moving to the backward stage. Okay, you are going to the you are moving towards, you are starting from the destination, you are moving towards the source. So you were in 5th stage, now you have to focus in the 4th stage. Now you have to calculate the cost of 9. Okay, so now from 9, what is the cost? You can see only one edge is there to 12, only one edge. So here no doubt is there. Okay, you can simply write the cost of 9 is 4. And where you are leading, where this 9 is leading to which, sorry, this 9 is leading to which vertex? This 9 is leading to vertex 12. So you have to write here 12. Okay, and you can see from 10 to 12 only one edge is there, and the cost of 10 is 2, and where it is leading to 12 only. Okay, and from 11 also only one edge is there to 12, and this is what is the weight of this edge? It is 5. The cost of 11 is 5, and it is taking you to the edge, the vertex 12. Okay, so you will write 12. Now you are at the stage third. You are at the stage V3. Now you have to calculate the cost for 6, 7, and 8. Okay. Now you can see from 6, how many edges are there? How many paths are there from 6 to the next stage? To the stage 4, how many paths are there? 2 paths are there. Now you have to take the minimum of these 2 paths. Okay. Then you have to take the minimum of these 2 paths. So you will write like this. Okay, cost of, you are going to calculate the cost of 6 for the stage 3. So you will write like this, 3 comma 6. This is 6. You are going to calculate the cost for 6, which is present at the stage 3. Okay, so you have to take the minimum value out of these values which is present here. You are having 2 paths from 6, isn't it? So you have to write like this, C of the cost of edge 6 comma 9 you have to write, plus you have to write the cost of 9 which is present at the 4th stage. Okay, what is the cost of 9? And then comma, you have to add, you have to fill the data related to the next path also, 6 comma 10. So 6 comma 10 is there, 6 comma 10. You have to add, and you have to add the cost of 10 which is present at the stage 4. Okay, sorry. So what you are seeing here, so when you are I want to delete this. We have a shortage of space here. So what I will write here, so see, so when you see like this, okay, so here what you're going to see, cost of, so you just calculate minimum of and this is what minimum of sorry, so I forget to draw this curly bracket here. Okay, this is curly bracket, this is within the curly bracket. Clear? Now you have to add a cost of 6 comma 9. What is cost of 6 comma 9? You see here, cost of 6 comma 9 is 6. Okay, so you will write here 6. You will write here 6. And then this plus. Okay, you add this plus. And what is this? Cost for cost of 9, which is present at the stage 4. And what is the cost of 9 at the stage 4? So cost of 9 is 4. You can see like from here. Okay, cost of 9 is 4. Okay, and what is cost of 6 comma 10? So you have to go to the edge 6 comma 10 and you have to write the weight from there. And what is that? 5. And you have to add the weight 5 plus cost of 10. What is cost of 10? Cost of 10 is 12, which is present at the stage 4. Okay, cost of 10 is 2. And now out of these two values, you have to get the minimum. That is what written in this formula. Okay, 6 plus 10, 4 is 10. And 5 plus 2 is 7. Okay, so which is the minimum value? Obviously 7 is the minimum value. Okay, and from where you got the 7 value? You got the 7 value when you have chosen the path 10. Okay, so you have to get the, so for minimum, for when you are going to fill this table, for cost of 6, what you will write? For cost of 6, you will write, for cost of 6, you will write here, what is you will write? You will write 7. Okay, and why, from where you will, you got this 7? You got this 7 from taking the value 10. Okay, From this figure, you got the value 7, isn't it? So you from this vertex 10, when you chosen the path 6 to 10, you will get the value 7. So you have to write this value 10 here in the D place. Okay. So this 10 is vertex 10 gives you the minimum cost for cost of 6. Okay. Now you have to calculate the cost of 3, 7 also. So now for you got the cost of 6, now you have to calculate the cost of 7. So similarly, you are going to calculate the okay. So how you have to put that in the formula, and you have to write like this. I will write here cost of 7, which is present in the third stage. Okay, cost of 7 is equals to min value of cost of what? 7. From 7 you can see two paths are there, 7 to 9 and 7 to 10. So you have to choose which path you have to take, which path is giving you the minimum value. Okay, so you have to first calculate for 7 comma 9, and you have to add the cost of 9, which is present in the stage, which is present in the stage 4. Okay, and then cost of 7 comma 10 added with cost of your 10, which is present in the fourth stage, and you have to get the minimum value. So you can see what you are getting. You are getting min of cost of 7 comma 9. Cost of 7 comma 9 is what? 7 comma 9, you can see it is a 4. Okay, and cost of 7 comma c of 7 comma 9 means what? It is the edge from 7 to 9, and you have to write the weight present on that edge 7 to 9, and that is 4 here. Okay, and you have to add that 4 with cost of 9, and when you see the table, you can see the cost of 9 is 4, so you will write 4 here. Okay, and cost of 7 comma 10, you have to see, you have to look on the edge 7 10, and you will find the cost present there, the weight present there is 3, so you will write 3, and you have to add that 3 with the cost of 10, and you get the cost of 10 from this table, and you will get 2 from this table. Okay, so which is minimum? You have to take the min value. So 4 plus 4 is 4 plus 4 is 8, and 3 plus 2 is 5. Okay, so which is the minimum value? The 5 is the minimum value, isn't it? Okay, so this 5 is the minimum value, and this 5, from where you got this 5? From where you got this 5? You got this 5 when you added C of 7 10 plus cost of 4 comma 10. Okay, that means from 10 you got this 5. Clear? So you will write the cost of 7 as 5, and the vertex which gave you the minimum value is 10. Okay. Now, next you have to calculate the cost of 8 in the similar way. Okay. So let's do once again. So cost of 8 is in which stage? 3. And we are going to calculate the cost of 8 using the formula minimum C of from 8 you can see two parts are there. So you have to calculate 8 comma 10 first plus cost of 10, which is present in the fourth stage. Okay, and then you have to add, you have to get the value of 8 comma 11 also. You have to get the value of 8 comma 11, plus you have to add that cost with the cost of 10 11. You have to add the cost with cost of 11, which is present in the fourth stage. Okay, so now you have to put the value here. So min C cost of 8 comma 10, you have to look on the edge 8 comma 10, and the value present is 5. Okay, so you have to write the weight 5, and the cost of 10 is you can see that cost of 10 is 2. Okay, so this is, and then cost of a C of 8 comma 11. You have to look on the edge 8 11, and the weight present is 6, and the cost of 11 you can see it is 5. You can get that from the table. Okay, so you can see the importance of table. We have calculated the value cost of 9, 10, 11 once, but we are reusing that several times. Okay, so we don't have to recalculate again and again. So this is a beauty of dynamic programming. So you can see 5 plus 2 is 7 and 6 plus 5 is 11. So which is the minimum? 7 is the minimum value. Okay, 7 is the minimum value, and you are taking 7 as the cost of 8. And which edge gave you the minimum value? The edge 10, the vertex 10 give you the minimum value. Okay, so you have to write the minimum value as, so cost of 8 is 7, and the minimum value which gave you 7, the vertex which gave you 7 is 10. So you have to write like this. Okay. Similarly, you have to calculate the cost of all the vertices present in stage 2. Okay, let us do. So that means the cost of stage 2 and vertex 2. You are going to calculate like this: minimum of, from 2 you have 3 parts. So you have to write the 3 parts, and from that 3 parts you have to choose the minimum value. So C of 2 comma 6 plus cost of 6. Okay, and 6 is present in the third stage. Okay, and then 2 comma 7 plus cost of 7. Okay, and that 7 is present in the third stage. Then cost of 2 comma 8 plus cost of 8, and that 8 is present in the third stage. Okay, now here you have to calculate equal to minimum value. You have to getting the minimum value. So first you calculate C of 2 comma 6. So you check the edge 2 comma 6, you will get 4, and you have to add the cost of 6. So you will get that value from this table, and it is 7. Okay, and then you can see 2 comma 6. You have to focus on the edge 2 to 7, and you will see the weight 2 is there on that edge 2, and you have to add that 2 with the cost of 7, and the cost of 7 is 5. You can get that cost from the table. And then you have to focus on the edge 2 8, and the weight of the edge 2 8 is 1, and the cost of 8, you can get the cost of 8 from the table, and it is 7. Okay, now you have to calculate all these things. So 4 plus 7 is 11, 2 plus 5 is 7, and 1 plus 7 is 8. So which one is the minimum value? Minimum value is 7. And which is giving this minimum value? Which vertex is giving you the minimum value? The vertex 7 is give you the minimum value. Okay, so you have to write that. So the cost of 2 is 7, and the vertex which gives you the minimum value is 7. Clear? Likewise, you have to calculate the values for cost of 3, 4, and 5. Let us do it. Cost of 3, and which is present in second vertex. So this first value indicates the stage number, and second value indicates the vertex value. So you are calculating the cost of 3, which is present in the stage 2. Okay, so minimum. Again, from 3 you can see 2 parts are there. So you have to find like that 3 comma 6 first plus cost of 6, which is present in the third stage. Okay, and then C of 3 comma 7 plus cost of 7, which is present in the third stage. Okay, now equal to min 3 comma 6. You focus on the edge 3 comma 6. It is value is 2 plus cost of 6. You can see the cost of 6 is 7. You can get that from the table. And then you have to focus on the edge 3 comma 7. The value on the edge 3 comma 7 is 7, and you have to focus on the cost of 7, which you can get from the table. Cost of 7 is 5. Okay. Now the value minimum out of this mean 2 plus 7 is 9 and 7 plus 5 is 12. So which is the minimum value? Obviously 9 is the minimum value. And which vertex is giving you the minimum value? The vertex 6 is giving you the minimum value. Okay. So you have to fill that value here. So you have found the value of a cost of 3. The cost of 3 is 9. And which vertex gave you the minimum value? The vertex 6 gave you the minimum value. Again, you have to calculate the cost for 4. So do it fastly. Cost of 4, which is present in the stage 2, is equals to minimum of, from 4 you can get, you have, from 4 you have only one vertex, okay, isn't it? One edge is there, one path is there. So it is easy. 4 comma 8 plus the cost of 8, and the 8 is present in the third vertex. Okay, so equal to minimum value. Cost of 4 comma 8, it is 11. The edge is having the weight 11, and cost of 8 you will get it from the table, it is 7. Okay, so it is equals to 18. And which vertex is giving you the value 18? It is giving, the vertex 8 is giving you the value 18. So for the cost of 4 is 18, and the vertex which gave you the value minimum is 8. Okay, now you have to focus, you have to calculate the cost of 5. So here you can see we have two parts for 5. Cost of 5. So first you have to calculate the cost of 5 for this. Okay, equal to minimum of two parts are there. So you have to write like this: 5 comma 7, cost of 5 comma 7 plus cost of 7, which is present in the third stage. Okay, 5 comma 8 as cost of 8, and cost of 8 is present in the third stage. Okay, so equal to mean 5 comma 7. When you focus on the edge 5 comma 7, it is 11 plus cost of 7. Cost of 7 you will get it from the table, it is 5. And you have to focus on the edge 5 comma 8, and it is 8. The weight is 8, and you have to get the cost of 8 from the table, it is 7. Okay, just calculate it and get the mean value. 11 plus 5 is 16. 8 plus 7 is 15. Okay, so which is the minimum value? Obviously, the minimum value is 15. And from where you got the minimum value? You got the minimum value from 8, vertex 8. Okay, now you have to fill that. So cost of 5 is 15. Okay, and which vertex gave you the minimum value? The vertex 8 gave you the minimum value. Okay, now we have to calculate the cost of 1. So we reach to the last vertex. Clear? Cost of 1. So 1 is at the stage 1, and cost of 1 is equals to, from cost of 1 we have 4 parts, minimum of, so you have to line cost of 1 comma 2 plus cost of 2, which is present in the second stage. Okay, then cost of 1 comma 3 plus cost of 3, which is present in the second stage. Then cost of 1 comma 4 plus cost of 4, which is present in the second stage. Then cost of 1 comma 5 plus cost of 5, which is present in the second stage, equal to min. So C of 1 comma 2 is 9. 9 plus cost of 2. Cost of 2 is 7. You can get it from the table. Then cost C of 1 comma 3. Focus on the edge 1 comma 3. It is 7. The weight is 7 plus cost of 3. Cost of 3 is 9. Okay, and then cost of C 1 comma 4. So weight is 3 plus cost of 4, you will get it from table 18. And 1 comma 5, it is 2. And the cost of 5 is 15. Okay, you will get that from your table. And now you have 4 values, and now you have 9 plus 7 is 16. 7 plus 9 is 16. 3 plus 18 is 21. 15 plus 2 is 17. Okay, now which is the minimum value? So you get 16. Okay, 16 is the minimum value. And from where you are getting 16? From two vertices. Two vertices are giving you 16. The vertex 2 is giving you 16, as well as the vertex 3 is also giving you 16. So you have to fill that in the table likewise. So the cost of 1 is 16, and the vertex which give you the value 16 is 2 or 3. You can write like this. You can either put 2 here, or you can either put 3 here. Okay, it's up to you. Clear? So 2/3, you can write like that. Okay, so this is how you have to fill the table using the calculation. Okay, so how the calculation goes on. Now, I hope you have written all these thing in your notebook. First, jot down everything what is present in the screen right now, and I will explain you the next process. Okay, so this is how you have to calculate the cost of each vertex. Okay, and after that, since this multi-stage programming is following the strategy dynamic programming, so you have to have a set of decisions at each stage. At each stage, you have to choose which path you have to opt. Okay, so that means when you are at the second vertex, there are 3 paths. Now you have to decide where you have to go. Okay, which path you have to choose. Okay, so so that decision you didn't make till now. Okay, I will. So that decision we will do from this D calculation. Okay, so you see from first, so how the calculation goes on. So just a second. So you see from first, you are the value is 16. Okay, you are starting from the vertex 1. So from vertex 1, which value you are giving you the small minimum value? The vertex 1, you are giving the when you are going to get the shortest path. So vertex 1, you are moving towards the vertex 2. Now, when you reach the vertex 2, you have to check which vertex gave you the minimum value. The vertex 7 gave you the minimum value. Okay. So, and from 7, when you go to the 7, you will see this is your 7. And which vertex gave you the minimum value? Vertex 10 gave you the minimum value. Okay. And here from 10, you will see which vertex gave you the minimum value, vertex 12. So this is one of the shortest path. Okay. Other way, if you are going to take the second option, so you can choose that means the value cost of 1 is 16, and that 16 was provided by the vertex 2 and vertex 3. So you can choose vertex 2 as well as vertex 3. So when you are choosing 3, so you check you are going to 3, and the cost of 3 is 9, and that minimum value is provided by the vertex 6. Okay, now you will go to the cost of 6. You will see it is 7, and the minimum cost is provided by the vertex 10. And then you will go to the cost of 10, and the minimum value provided is the vertex 12. So this is your 12. So there are 2 paths are there: 1, 2, 7, 10, 12, and 1, 3, 7, 10, 12. Okay, so when you add both the paths together, you will get the value 16 as the minimum value. Okay, so you just add up 1 to 2. What is the path value? 1 to 2, it is 9. 2 to 7, it is 2. Okay, 7 to 10, it is 3. Okay, and 10 to 12, it is 2. Now add all these things. 9 plus 2 is 11. 11 plus 3 is 14. 14 plus 2 is 16. Okay, now the another path, 1 to 3, it is 7. 3 to 6, it is 2. 6 to 10, it is 5. 10 to 12, it is 2. Just add up all this. 7 plus 2, 9. 9 plus 5 is 14, and 14 plus 2 is 16. So both the shortest paths, both the paths are giving you the same value, 16. Okay, so you can choose either of these two paths. Clear? So this is how you are getting the minimum shortest path from source to destination using dynamic programming strategy. Okay, now you can see from here you have used the 3 rows you have utilized. Okay, what is the importance of these 3 rows? So this much you write down in your notebook. And now I am stop sharing this one and I will share another video, another screen to you. Okay, just a second. Okay, so this is the neat drawing of your multi-stage graph. You draw it from here. And this is the algorithm that we have used here. Okay, so this is the F graph, forward approach using. Okay, forward graph. Okay, so G is the graph, our original graph. K is the number of stage. How many stages are there in this graph? 5 stages. So for K we will write 5. N means total number of vertices present in our graph. How many vertices are present in our graph? 12. Okay, so that is N is 12. And P is a minimum cost path. It is an array, name of the array. Okay, name of the array. And this array will contain how many cell? You can read this. The input is a k-stage graph G of V comma E with n vertices indexed in order of stages. E is a set of edges and small c of ij is a cost of I comma j. I comma j is an edge. Okay. And P is an array and it has got 12 cells. Okay. And it is a minimum cost path. Clear? So let us check how the things are happening here. So before, when you start the algorithm, you can see cost of n is equals to 12. And what is n? It is 12. So 12 is our last vertex, which is present in the last stage. Okay. So naturally it is 0. And we have already seen that it was 0. Okay. In our table also it was 0. Now you are going towards the source. So because of that, your j is from 12 minus 1 to 1. Step minus 1. You are moving towards the source. Okay, so first time your j value will be 11, then it will be 10, then it will be 9, likewise. Okay, and this d of j is equals to r. So this is a value, this is a formula that we used here. Cost of j is equals to cost of j comma r plus cost of r. Okay, and r is means what? R is a vertex which gives you the minimum value. Okay, so that is what we have written in that D column, D cells, okay, in our table. And D of J is equals to R. So when we work out this one, you will get that easily. Okay, and P of 1, so I will just draw this here, just a second. So I told you that P of 1. Okay, so this is your PL array and it will have 12 cells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 12. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 cells are there. So you can see in this line number 15, P of 1 is 1. So you have to put 1 here. You have to put 1 here. Okay, and P of K, that is P of 12 is N. That is N. N means our 12. Okay. Clear? 1 is to 12. Now, what do you have to write here? So, P of, you have to write like this. So, sorry. This K is your stage. No? So, here our stage is 5. So, you don't have to draw all these, you don't have to draw all these cells. I will. Okay, only 5 cells are needed. Sorry. This is array 1, 2, 3, 4, 5. Okay, my mistake, sorry. Okay, so 1 is filled here and next you are going to, P of k is 12. P of k means a P of 5. So this is 12. So you have to fill 12. So this array P is giving you the minimum cost path. Clear? So now for j is equals to 2 to k minus 1. So 2 is how many stages are there? 1, 2, 3, 4, and 5. Total 5 stages are there. And in the stage 1, the source vertex is there. In the stage 5, the uh, last vertex is there. So in the stage 1, you have written the 1. In the stage 5, you have written 12. Okay. And in between 2, 3, 4, so out of, in the from the stage 2, which vertex you have to choose. That is what happening here. Okay. And that is what happens in the 16th statement. So you are going to 2 to k minus 1. K is 5. 5 minus 1 is 4. So this loop will move for these three stages only. 2, 3, 4. So P of j. P of j means a P of 2. Okay, that means this index. P of 2 is equals to D of P of j minus 1. J minus 1. J is here 2. 2 minus 1 is 1. Okay. So what is P of 1? P of 1 is 1. So P of 1 is 1. So P of 1 is 1, you know that. So you will write here. Now D of 1. What is D of 1? You will go and check your table and you will find D of 1 is 2. Okay, 2 or 3. It is written like that, 2 or 3. Clear? And now, so this for this after this, your J value incremented, J becomes 2 here. Now, P of 3, that means this position, P of 3, you have to fill like this. You fill like this. So D of P of J minus 1. So J is 3. 3 minus 1 is 2. So P of 2. Okay. So P of 2 is what? P of 2 is your 2. So first put 2. So D of 2. You will go and check your D of 2. So when you will get D of 2, you will get that vertex. Okay. And here you will get that vertex. Clear? So you just indicate, you just focus on that table and you will get everything correctly. So just go through the video 1 or 2 times and work out this algorithm. If any difficulty, you can come to me. You can ask your doubts with me. Thank you. Thank you so much. So what happens in the when you compare this greedy method and dynamic programming, what happens when greedy method, what happens you see, suppose you are going to solve this multi-stage graph with greedy method. So what happens from 1 you have 4 paths. So greedy method will tell you to take the smallest path. So you will take naturally 1 comma 5. Okay, so this, because this gives you the smallest cost. From 5 you have 2 paths. So you will get you will take naturally 8. From 8 you will have 2 paths. You will take 5, this 10, and 10 to 12. So what path you will get? 1, 5, 8, 10, 12. And you just add up 2 plus 8 is 10, 10 plus 5, 15, 15 plus 2 is 17. So when you use greedy method, it will give you 17. And when you are using multi-stage graph, multi-stage dynamic programming, you will get 16. So which program strategy is best? Dynamic programming strategy is always best when compared to greedy method. So greedy method, it simply analyze at the first stage and it decides accordingly. But in case of the dynamic programming, it will analyze at every stage and then only it will come to the conclusion. So just I will give you an example. Suppose you are studying BCA and some student, when you are using greedy method, what happens? Suppose a student, Raji has secured 80% in the first semester. And when you analyze Raji using greedy approach tells that Raji will get 80% at the end of 6th semester also. Okay, but It may not be the case. At the end of the sixth semester, Raji may be securing only 50% or 60%. It is not necessary that she will secure 80% always. Okay, so dynamic programming is that things may change. So after taking every calculations, after analyzing everything, then only it will come to the conclusion. So this is the major difference between greedy method and dynamic programming. Okay, so thank you so much for being with me. Watch this video once or twice and understand. Try to understand. Thank you. Thank you so much.